Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. This is the second part of our discussion on foundations of business intelligence. Now here we would be talking more about how you would be using databases for organizations or for businesses. Now here, you could see that in a database management system, there are several activities that you could do and you would be doing. First, you would be designing a database. Now the database would first consist of the conceptual or logical design. So this is an abstraction of a business perspective. Let's say you have a certain business process in which you would be trying to process and trying to procure spare parts for a company. That's the business process. Now you have to identify what are the entities that are needed to do that process, and then what are the relationships between those different entities. And then you would be physically designing the database in which you would be designing the storage of data. The second activity would be designing process, which would be making a more detailed interpretation of the relationships between data elements. And then you would be normalizing the database tables in order to avoid redundancy and make sure that the relationships are properly done. This is an example of a normalization process. Here you can see that this table consists of several fields which are all in one table. And this is not practical because then every time you have a new record, then you would write again the number of the order, the date of the order, the name of the part, the supplier number, the supplier name, and this is not practical because there would be lots of redundancies. For instance, if a certain part would be ordered several times, then you would continuously write the name of the part, the supplier number, the supplier name, and so on. So in order to normalize this database, you would be making it into something like this. You have the part table, you have the supplier table, you have the line item table, and the order table. Now, each of these tables has what we call a key field. The key field would be usually a number, which is unique to each entity. So a certain part name would have a certain key field part number, and no part would have two part numbers, and no part number is assigned to more than one part name. Okay, it's a primary key because it comes from this table. The supplier table also has a key here. The supplier number is the key field or primary key. Line item also has a key field. Actually, it has two. It has a primary key, and it could have a primary key or a foreign key. Now, in this case, it seems that both of them are foreign keys. Okay. And you have an order table with order number as the key field. Now, if you design a database, you would have to also describe the rules that govern the relationships between tables. And then you could make it into an entity relationship diagram, which would be showing the relationships between the entities in a database. And you have to get it right because the system would be based on this data model. And if it's not correct, then it would not be able to work as intended. For example, here is an entity relationship diagram which has 4 entities. Now, these entities, you would get the information on what are the entities, of course, from the, you can say the business owner, maybe the users, and you can get more information and detailed information on what are the entities needed for a certain process. In this case, let's see here, you have a supplier entity, you have a part entity, and these entities are connected with each other. And you can see here, these are the symbols that show the relationship between these entities. A line here would be representing 1. A branch like this would be representing more than 1. This is how you read it. A supplier would provide 1 or more than 1 part. Okay. Meaning a certain supplier like CPM Incorporated might be providing several, maybe even hundreds of types of parts. But on the other hand, a spare part is supplied by one and only one supplier, meaning that there are no other suppliers that provides that same part aside from the assigned supplier here. A part is provided only by one supplier, and so on. Now, databases would be made to improve the performance of businesses and also to improve decision making in terms of accuracy and also in terms of speed. You would be discussing and seeing discussions on big data. But in the future, there might be a different term used to describe big data because sometimes it's just a fad, but the idea is still there. The idea of big data is that you would be managing a huge amount of data, which is unstructured and semi-structured. Now, the data that you would use in a database table and a usual database table is structured because you have those tables and you have certain fields, certain records, and you have certain formats needed for each field and so on. This one, big data, is unstructured and it's massive. So if it's still data from a certain company, it's still usually not that massive. You might have, let's say, thousands of transactions a day. That's still not that massive. The level of massiveness is at the level of the data that is captured by Google. You can imagine how many millions or even billions of people go to Google to search something, and then every day they would be searching how many times? That's a day. So it could be billions of data that's captured in a day. That's from web traffic. It could be from social media. You can imagine how many times you send a message each day on, let's say, WhatsApp or Facebook or Instagram. Well, in the others, Facebook, Instagram, the data would include different formats, sometimes pictures, sometimes videos. That's why it's unstructured. You couldn't really have to dictate what type of data you're using. And then sensors, for instance, pressure sensors or movement sensors put on mountains, for instance, or let's say cameras, CCTV cameras that are deployed by government on the crossroads to figure out if there are incidents of crashes and so on. That's a huge amount of data there. It could be at the level of petabytes or exabytes of data. So typical DBMSs would not be able to handle that level of data. Now, big data can reveal patterns and anomalies. So using huge computing power, you can process all that data and then find out specific patterns of human behavior, of customer preferences, customer behavior, and so on. Now, big data could also be used for business intelligence. This is basically the process, the activity of trying to capture information and capture data and process data in order to gain insight or more understanding about what's happening in a company or in the environment of a company. And there are several tools that you could be using, like for instance, data warehouses, data marts, Hadoop, in-memory computing, and analytical platforms. You have some descriptions here: data warehouse, data marts, and so on. And here's a simple representation of all those definitions. Basically, on the left side, you can see several data sources, operational data from the company. Let's say you have historical data from the archives of the company, and then you have web data from the websites. It could be on video or audio, other data from outside of the company. Then you would be extracting this data into a data warehouse. Okay. The data warehouse combines all this data. So it's a compilation of different data sources. And of course, it's not practical to analyze all that data if you don't really need all of those. So in that case, you would be using a data mart, which would be a subset of this data warehouse used by different users. It might be used by the marketing department, the financial department, and so on, which they would be trying to query, meaning trying to find certain data from the database, or trying to generate reports, let's say financial reports, marketing reports, or a dashboard to show the condition of that company in graphical form, in diagrams, and so on. Now you have Hadoop cluster. The Hadoop cluster would enable massive amounts of data to be processed using computers or using gadgets that do not have large computing power. Okay, this could be directly used by the power users. The power users might be managers, high-level managers that need considerations in making strategic decisions, for instance. They would be using an analytical platform to do the queries, reports, online analytical processing, and data mining. These are higher level than the casual users. You have more information on Hadoop here. In-memory computing, basically, if you process the data in RAM, in random access memory, it would be much speedier, faster than if you would be processing it from the hard disk. And there are analytical platforms used to process the data as well. Now, we would be talking about another kind of analysis. It's multidimensional data analysis, or OLAP for short. When we think about data, we usually think two-dimensionally. Okay, you have an x-axis, you have a y-axis, and then you make a chart on that. But actually, data that the company has is not just two-dimensional. It would be multi-dimensional data. For instance, here, this is just a three-dimensional data. Data could be more than 5, more than 10 and so on dimensions. So what we could do is show it in 2 dimensions. In this case, for instance, if you slice this cube this way, you would be getting data on product versus region. If you slice it this way, you would be getting data on projected sales and actual sales, this one, versus region. If you slice it differently, you would be getting different perspectives of the data. And OLAP is used to slice and dice these different dimensions. Data mining, you would be trying to find out relationships in data sets. For instance, here, you can do text mining. Text mining is trying to find keywords, for instance, in a call center transcript. When you're trying to capture the complaints of customers, you make a transcript, and then you could find out what are the largest number of complaints about from this transcript. Legal cases, service reports, and so on, these are unstructured data, and you would be text mining that. Sentiment analysis is an analysis of text in social media. And the purpose is to find the sentiment of the public about a certain thing. Let's say you want to know, how do people think about Toyota or Honda? Okay, and then you would be scanning social media to find keywords that are either positive or negative. And then you compile it, and then you can see people are, let's say, 75% positive and 25% negative towards Toyota. Honda may be another mix. That's sentiment analysis. You could be web mining, trying to find out information on the content of web pages. And then, of course, databases would be accessed through the websites. Okay, you can see here how it's done. You have client. This is the user, let's say a customer, an e-commerce customer, let's say. And they access through the internet. And what they would be accessing is a web server. The web server does not have directly the database there, not even the application. The application would reside in the application server. And then the database would be in a different server. Okay, so there are three levels of security there. If a certain hacker would be hacking a web server, they might not be able to access the application server and not be able to change the database server. Also, it would be easier on computing resources. And then you would also, in managing a database, have to establish information policy. For instance, who administers, who governs the data. And then you would have to ensure the quality of data, because it seems that even in the Fortune 1000 companies, these are large companies, 25% of them do not have good database management. Some of them are redundant, inconsistent, and even the input could be faulty. And then you would be doing data quality audit as well, auditing, for instance, whether the data in the system is accurate and complete. You might be sampling data, or you might be getting end user perceptions on what they think about, subjectively, about the quality of the data. And often you would also need to do data cleansing to make sure that data is not redundant, to make sure that the correct writing is used, the correct format is used, and so on. Okay. So this was a discussion on the extended application of databases. I hope this was useful. And hopefully we would be able to utilize databases for the benefits of organizations and companies. Thank you, and wassalamualaikum warahmatullahi wabarakatuh.